SoftIron builds private cloud on-premises, the entire stack. And it's great to be here at Cloud Field Day and obviously live as well. My name is Jason van der Schyff. I'm the Chief Operating Officer of SoftIron. I've been with the company for about 10 years, and the company's about 12 years old, so not quite the founding team, but pretty much close there. I'm based in LA, spent a long time up here in the Bay Area. So SoftIron started like all great ideas around a water cooler. The premise that the IT industry had, by and large, sort of lost its way. We were building generic hardware with a bunch of ODMs. They were building it in far-off places, and the people whose name was on the front of the box had nothing to do with the design or the manufacture of that product. We'd really stepped away from the roots of innovation, and it's probably fair to say that the last company to take a real holistic approach of IT was Sun Microsystems. So our founders, Dr. Norman Fraser, who's now our chairman, Phil Straw, our CEO, and Mark Chen, our CSO, have all previously worked together in a number of chapters. And in fact, much of our team have worked together over a number of companies and a number of decades. Norman is a serial entrepreneur, having taken 2 companies that he founded public, and who knows, SoftIron might just be the next one. So 11 years in, our mission remains clear: to simplify and streamline IT infrastructure and enable a public cloud experience on-premises infrastructure you could actually live with. So we do this by delivering a true private cloud. Our team's background in deep tech and security has driven the focus on this to not only deliver cloud-like agility and simplicity, but to provide a secure by design approach while we do so. This is suited for running the most important and sensitive workloads and data, things that you might expect to see in a private cloud. So today we're trusted by some of the largest, most reliability and security concerned companies in the world. These are the ones that we're allowed to talk about, and they include companies across finance, research, national security, and within federal agencies. There's a snapshot here, and we'll talk more about solving our customers' problems a little bit later. So one of the unique aspects of SoftIron is the end-to-end control that we have over the entire solution. The enterprise IT industry is peculiar in that it's one of the only industries where we demand high performance, high reliability, yet by and far, for the most part, we outsource most of the design and manufacturing to low-cost labor markets with variable levels of quality control. Lockheed Martin doesn't do this with the F-35. Ferrari doesn't do it when they make a car. And as we spoke about this morning, Flemings don't do this when you go and get a steak. So our in-house team of hardware engineers design every circuit on every circuit board, and we manufacture the products ourselves. Our software engineers compile every line of code from source, be that SoC firmware, network drivers, the operating system, all the way up to the application space. We recently became a CVE numbering authority, taking responsibility for the assignment of CVEs to any vulnerabilities in our code base. We even cross-check that CVE database on every build at every part of the stack. It's because of this that we can provide a level of auditability of our solution that we call secure provenance, and we'd be happy to talk about that a little bit later. We currently operate 2 manufacturing sites, one of them just across the bay in Newark, and the other one in Sydney, Australia. Our Sydney facility was co-funded by the Australian Department of Defence under what's known as a sovereign industrial capability. No one has ever built computers in Australia before SoftIron. We'll now take a quick virtual tour of our Bay Area manufacturing facility.
Can you just expand on what the thinking was behind the investment by the Australian government? What prompted them to make that? I can guess, but...
So they have some neighbours to the north. It's a very tense geopolitical area. And the Australian supply chain is massively dependent on things coming out of other places. Australia is really good at digging stuff out of the ground and sending it in other directions and receiving finished products as a result. And at the time that someone like IBM was building in White Plains and building in Warwick, Australia was paying people to move to the country. So by the time the economy caught up and became the size that it is today, we were already manufacturing in Southeast Asia. So they've sort of missed that entire skill base. And the government across the board is investing heavily in advanced manufacturing. They're trying to get into semiconductor manufacturing as a part of that. But they have this sort of interesting problem, which is it's a small population, it's a fairly large economy, but we've invested in skills that are tied to the mining industry, resources. We haven't invested in manufacturing. We've tinkered with some submarines, which varying levels of success. And so they're very much trying to sort of invest in that. So the idea being that they can start to build products end to end without relying on that. And it was just highlighted like everywhere with COVID, which was suddenly
it's a response to global supply chain. And
exactly. And they think that it will ultimately get worse. So if shipping lanes are restricted more, as we're seeing in the Red Sea right now, it's not going to be a good day out.
Makes sense. Thank you.
Nice. There's normally an audio track, but I'll speak over it on this instance. So the manufacturing extent that we do is we run our own surface mount assembly lines. So we do all of the PCB-A population. We're able to do it in fairly small batches. So for manufacturing folks, when they look at this, we appear to do things in a slightly different way. We don't use large reflow ovens that require profiling, that have variability around what's happening in the humidity, in the environment around humidity. We use batch mode vapor phase ovens because we're the ultimate definition of very high mix. So we can go from building a tiny network card all the way to a very, very large motherboard in small batches, one after the other. And it means that we can turn that around much quicker. We do all of the final box build assembly. Well, we don't show it in this video because screwdrivers aren't that interesting. But we do it all here. The way that the two manufacturing sites work is they use identical equipment. So all of the SMT equipment that we use is exactly the same in both places. That allows us to basically have a central source of truth from a code base perspective on our manufacturing files. I'm going to keep playing. And so we use software control techniques like Git to actually manage our manufacturing files. So if we change something in one factory, that change is then reflected as a commit to the next manufacturing build. So we're able to guarantee that every product is built in exactly the same way with the same files, 10,000 kilometers apart in completely different time zones. On the box build side, we managed to, we designed the assembly process ourselves. As you can imagine, there's not a lot of availability of server assembly machinery. Basically, people don't do it. So we have a team in Berlin that specifically work around manufacturing and sort of that productionization stuff. Obviously, Germany is pretty good at that stuff. And so we've implemented that in both factories.
Question about that, if that's okay.
Yeah.
So just out of curiosity, if you can share, I mean, it's awesome that everything's built in-house, that it's not outsourced, et cetera. What was the particular reasoning? Was it just SoftIron wanted pure control over what was going on? I mean, y'all didn't want to send it out here or there, get this part back, get this, try to piece it together and say, this wasn't working, this malfunctioned, et cetera. You just wanted to know exactly what was going on, exactly what was going into it, and ship it out the same exact way every time.
Fair to say we're control freaks.
Yeah, fair enough.
But there's also, from spending time with you guys, there's some requirements from some of your potential customers looking at some of the locations you're in and geopolitical relationships that some of those locations may have.
Got it. Makes sense.
You can see why that it would be appropriate.
Yeah, there's obviously a large desire for things that are made in America or made in Australia.
Sure.
Australia, the UK, the US.
Yeah, makes sense.
May have this tripartite security arrangement. Yeah. Look, a part of it came from that. The other thing is when we set out to build a company, we knew that what we wanted to do was pretty audacious. You don't turn up and say, we're just going to change the way IT looks, right? And there's a lot of things that filter through the business as to why it looks the way that it does. So on a previous slide, we talked about the equity financing that we've raised. We've not raised that from traditional VCs. Because the example is they have a 7-year fund cycle. If you haven't made it in 7 years, they're going to shove you into a portfolio company or ditch you. And we were never going to do this in 7 years because it's really hard. And it gets harder once you're about 7 years in, you realize what you actually have to do. So there was an efficiency of capital in also manufacturing. If you go to one of these big CMs on Oakmead Parkway, they don't want you to build one. Or if they do, they're going to charge you for the privilege. And what we worked out very quickly, and based on the team's history, the CEO and myself both come from a manufacturing background, is the truth is it's really not that hard. It gets hard at scale, but it's very hard to build one without a lot of money. It's very easy to build 10,000, and there's a gamut in the middle where it's really difficult to do that. The easy answer is you go and find a contract manufacturer in Asia because they won't charge you as much. But then you start to say, we've spent all of this time on really secure designs. We've spent a lot of time on security in the software stack. And now you've just created a massive attack surface by going and building elsewhere.
Right. Yeah.
So it's sort of
awesome.
a balance between those two.
It's compelling.
So let me try and get back to sharing the right screen here.
So given that you're manufacturing your own, how much of a premium is there?
It's a good question. So you would expect me to say we're twice the price or something like that.
30%.
30%. We generally compete dollar to dollar with both the big OEMs and also white box providers. And there's a reason, which is all tethered to the design of the product. So take one of those big vendors. They build a 2U server. They have, during design and during manufacture, they have no idea what that server is going to be. It could be a database server. It could be a web server. It could be just storage. They don't know which network card you're going to put into it or how many network cards you're going to put into it, if you're going to put a GPU into it or anything like that. So they have to be able to support as many of those things as they possibly can. So we see lots of expansion slots. Well, to put those expansion slots in there, the connector doesn't cost much, but because you don't know what someone's going to put in there, you have to be able to support the spec all the way to the most extreme. So if I put 4 PCIe slots, I need to be able to support maybe 4 GPUs. That means I need to deliver each of them maybe 150 watts each. Now, my small power supply isn't going to be big enough, so I put big ones and lots of them in. And so you end up with all of these components that take up space and they cost money. And we get rid of all of those things because our storage server is only ever going to be used for storage inside a HyperCloud environment. So you won't find a PCIe connector anywhere in any of our servers because the only time we have a PCIe connector is in a GPU product designed to have a very specific GPU plugged into it. And so there's a massive saving across the entire product range by just not having to have bits which may or may not ever get used. It also makes it cleaner, so it generates less heat, we use less power, and so we start to get some of those second order savings. So on a box-to-box basis, we can generally compete, and then we generally blow it away when we move to a TCO calculation.
So each server is ordered, designed for a specific use, and is never flexible for something else. At one point, if you don't need that server, you're not utilizing it, or it's been recommissioned for something, it sits there until you're ready to use it, like a storage server or a database, or like you're expanding the network and want to put additional cards in. You can't do it on that. You actually have to order one to specs.
So they're not quite order to spec, but they fall into categories. So we have storage servers, which are spinning disks, NVMe, SSD, compute nodes with certain amounts of cores and RAM configurations, but they all come together as a pool of resources that can be used depending on what the workload is. So it just presents itself as this sort of big pool.
So would it be fair to say that your average customer is ordering at the rack scale?
Rack scale and beyond.
Right.
Yeah.
So there's I need a pod to do this, and that's going to be 4 or 8 or 16 racks. So that's going to be a pool of resources that functions together as a unit.
Mhm.
That's what you're targeting, not someone who's like, yeah, I need 4 servers to go in this rack. You're like, well,
Yeah. So our minimum configuration is down at 8U,
okay.
and that is entirely self-contained, a private cloud, including the networking stack around that, but it will scale basically limitlessly.
I have so many questions about the software that's driving this.
He's going to be the man to talk about
Okay,
that.
so I will hold my software questions until then. I just want to comment that at an 8U scale, I know this from other private cloud solutions, the footprint of the control plane is non-trivial. So you might get 8 or however many servers in 8U, but you're going to lose 50% of your capacity to the control plane and the management plane. So
Data plane. Way too few charts.
Yeah. There's a lot of benefits that we get by owning that entire stack.
I imagine, yeah.
As to where we can shove the control plane. And it might not be where you expect it to be.
I know you're manufacturing a lot of these components. What are the components that you're not manufacturing?
So we obviously don't fabricate chips.
Okay. So you're using...
We use AMD primarily on the compute side, so EPYC Gen 3 primarily. Across the board, we're pretty agnostic around vendors. We do a lot of diligence around where the chips are designed and where they're made, for obvious reasons. But we're not necessarily wedded to, hey, we only use Intel on the network side, or we only use Mellanox on the network side.
Right.
We're pretty agnostic to solve the problem, which is either going to be the performance characteristics or the cost characteristic. So
a major security, potential security issue is the BMC. So are you buying your BMC from somebody else, or that's something you do in-house?
Yeah, so we do the BMC entirely ourselves.
Okay.
Because you know how this works, right?
It's an attack vector.
It's an attack vector, but there's 3 companies that write the BIOS, and there's 1 company that makes the chip. And those 3 companies don't give you the source code, they give you a binary file.
Right.
Trust us.
You shouldn't.
Certain people don't trust other people.
Exactly. So actually, there's not for now, but there's a good follow up, which is our VP of Platform Engineering wrote a blog post on why we chose to build our own BMC, and it is literally all of those ideas. But it also gives us way more control of the entire environment. So we're able to do really clever things like the nodes are stateless; they don't have boot drives. They identify themselves when they join the cloud because our hardware is aware of the software and our software is aware of the hardware. And we wouldn't have been able to do that if we'd gone and done a A-speed BMC with some code from AMI.
Right.
Okay. And yeah, it's a huge attack vector, right? Okay. So like cloud providers, we got our start delivering cloud scale storage systems, and that's the sort of genesis of SoftIron. So think about the first service for AWS, S3, simple storage service. We did the same thing because at the end of the day, it typically all comes back to storage. That's what people are generally caring about. Since that time, we've expanded our company, the footprint, and offerings to deliver on that same message, delivering a turnkey private cloud that dramatically simplifies the entire business of on-premises infrastructure. We believe that we've reached an inflection point in the industry. IT's evolution, where applications have been architected to run in the cloud, and that's really the new normal. So we asked ourselves, if that's the case, why do we still insist on building on-premises infrastructure from the same way we have been for the last quarter of a century? And arguably, why does it have to be so difficult? We all know that everyone's enthusiastically embraced the cloud because we like the benefits of the cloud. It's agile, it's elastic, it's simple, and that self-service consumption model really accelerates time to value. So most organizations are talking about this cloud-first approach, meaning new workloads go to the public cloud. What became really interesting for us when we sort of dug into this, and these numbers come from a Flexera report last year, is whilst the public cloud gets all of the headlines, 76% of organizations are still running things on premises. 3 out of 4 organizations have workloads that have to remain on premises for either security, privacy, massive data stores, or performance reasons. And they need to run it at, they want to be able to run it themselves.
So just on that data, I think by vertical, you could see that being different and significantly different. And if you look at banking, they're at between 5 and 10% adoption of public cloud.
Mm-hmm.
Everybody says public cloud's the answer. Everybody says we've all moved to the public cloud. The industry says public cloud's the answer. You actually go and look at the data for certain regulated and highly regulated industries. Banking public cloud adoption is at 5%. You look at some of the other people you're targeting from a government perspective, I'd argue it's maybe less than 5%. I think that probably a more nuanced view of that by vertical may help you.
Yeah. Because we definitely.
I don't disagree with that generically as a slide, but
we could maybe make our case stronger by focusing.
Yeah,
on
I mean, some of the people you're targeting, they're nowhere near, 4% public cloud, and they probably won't ever be, much as everybody likes to think they will be.
Yeah, and I think to put it, obviously we've had the benefit of numerous chats with Stephen over the time, but we really do focus on those what we consider heavily regulated industries. So defense industry, obviously national security, energy, critical infrastructure. We're starting to see a lot of legislation being written globally around protection of critical infrastructure because we started to work out that it's great that we've connected our water treatment plants to the internet, but you can do a lot of stuff with that now. And so, very much this sort of idea that that's a sweet spot for us to operate in and around because of all of the sort of second order security properties.
I have a question, and apologies if you're going to get to this later, and then I'll shut up. But is it your own OS running on top of the hardware?
Yeah.
Okay. And is there the ability to like swap if you wanted to? Like, could you do something like Azure Stack HCI on top, or OpenStack, or something along those lines, or is that like a big no, it's proprietary?
So at that level, it's proprietary. You want to swap that. You wouldn't be able to,
right?
But you also wouldn't want to,
right?
Because what you're getting out of those platforms, we would arguably delivering in a superior way, as it is. What we do allow is inside the application space, you can run any manner of applications inside VMs, and we've got.
So it could be anything from VM-based environment to an orchestration-based environment, like Kubernetes or Nomad or whatever. Yeah.
Yep. Okay. So VMs, micro VMs. So basically the same as Lambda.
Got it. Yeah.
We don't provide as much wrapping around that as Lambda does, but you have the ability to do so through the API.
Cool.
And then obviously all the container stuff naturally.
And I want to jump in there on that. At 72%, that is a hybrid environment. And I apologize if you're going to get to it or you've already talked about it. Is that what's your connectivity to the hyperscalers in order? Because everybody wants to try to do hybrid. There's 4% private.
Yep.
So some subset of that applications are still going to want connectivity to the cloud.
Yeah. So I might just do this slide.
Okay.
It'll make sense.
It's like we had a conversation already.
Right. No, it's right. And this is the sort of rubber on it is absolutely a hybrid cloud world. And if you want true evidence of that, it's the fact that all of the 4 big hyperscalers, Amazon.
There's 4 of them?
Well, I'm being generous to Oracle, maybe.
I didn't say it. So.
IBM would.
I say
IBM, Oracle, OVH Cloud.
Yeah, Tencent.
Oracle doesn't get.
I had Oracle.
It's Ali Cloud.
All right, you better get control of this group. You've lost.
So anyway, I'm really curious about this. I'll drag him back in.
Yeah. So these are the ones that we think about. But if you look at Azure Stack HCI, Anthos, Outposts, that is, to our mind, the public cloud guys saying people want to run workloads on premises. Otherwise, they wouldn't do that. The challenge that you have there is it's not just a hybrid world. People want multi-cloud. They want to be able to have some things in AWS, some things in Google, maybe some things in Tencent, maybe.
That's
Um,
arguably a tough subject for this group.
we'll just
We'll
maybe
move
just
on.
move along. But all you're really doing at that point is creating more silos on premises, right? So you're going to have the AWS thing. And my view of the beauty of multi-cloud or multi-hybrid cloud is now you can do arbitrage. So if I'm on the West Coast, I get a different price to store things in AWS because there's a massive data center just down the road. If I'm in Australia, there ain't no real presence of Google, right? They are very much the also ran in a mostly Azure and AWS world. Now they might do a deal which they say, hey, we're going to give you really cheap compute. Well, I want to be able to move compute and burst workloads at some level based on how much it's going to cost me and where I want to be able to do that. We can do that from in HyperCloud. We can use them either as a storage endpoint, or we can burst workloads either into AWS, Azure, or through Anthos.
So you manage that, bursting the workloads into it?
Yeah, and you do it from within HyperCloud.
Okay, I got a bunch more questions on cloud costs and all that, but I'll hold off. But go ahead.
It's gonna blow your mind.
No pressure, Charles. That you're just going to blow their minds when you get to this.
Everything you know and understand is gonna get challenged.
Yeah, exactly. And so I think, where we look at this from, well, and we didn't coin this, turns out someone did a long time ago, cloud washing, is there are these folks that we put up on that slide that talk about having a cloud, and it's not a cloud. It doesn't look like a cloud. It's being marketed as a cloud. Because if you really want to have a cloud, you have to be able to deploy it easily, scale it easily, manage it easily, and consume those resources just like in a public cloud. The public cloud has taught us that we want to consume from the top down, where we only think about the workload and we just expect the infrastructure to be there and to run. We can't do that in today's legacy approach. You can with HyperCloud. So from a deployment perspective, we choose from a complete set of our task optimized nodes, storage, compute in varying varieties. We can deploy a cluster in half a day, if not less. And that is from the rack and stack cables in the back to a UI. We've done that on a number of customer sites where we've been eating pizza at lunchtime, running them how to administer their cloud. You can't get that when you are building a VMware environment or even a Nutanix environment. It doesn't exist. You need to be able to scale it, so that ultimate flexibility with scale out capacity. No 3 rack limits, no 42 node limits, or whatever that is. You need to just be able to go. So I can put 8U on the floor and I can grow that to a regional data center. It's all one cloud and it can all have shared resources. Because the narrative is you don't want to have the accounting team and the engineering team running on the same environment. Of course you do. Because accountants work 9 to 5 unless it's tax season, and engineers like to do kind of crazy simulations in the middle of the night. Well, if they're on separate silos, you can't share that resource.
But those separate silos, there's 2 reasons that we've seen that with the HCI devices systems. One is blast radius. And the second one is the distributed storage beyond 8 nodes on a like a VX rail or that kind of stuff. It's just sucky. No, whatever. Sorry, guys.
That's great.
Sorry, Del. It's not. It's just that when you get beyond it, I mean, that's the same for VX rail, or if we did, those other kind of other systems with VMware. So what have you done for the distributed storage to get beyond that? Because that's been consistently, every HCI we've had out there has had that problem, that they've hit that wall, and I haven't seen one yet that hasn't.
So because we view the storage and the compute as separate things, so they're not hyper-converged in any way, that storage is all software-defined, and it's going to get more resilient the wider you go. So it's going to be more performant, and it's going to be more resilient the more nodes that you actually add. So you want to have as big a shared pool as you possibly can, because it's going to increase the throughput on writes and reads, and it's also going to improve your resilience massively. You have less single points of failure across the entire environment.
So going off of her point, you're not going to have contention with the more nodes you have, the more read writes, the more buffer that's allowed that will be handle all the storage.
No.
Okay.
Next,
Next.
what's the recommendation there? Like to handle, I mean, you're talking about the storage at different layers of CPU, at different layers of it. And I'm with her on it is that I've seen a number of times where databases are running at heavy capacity and the read writes have just locked everything.
Mm-hmm.
So
Separate the pools.
Yeah.
The whole thing is meant to just expand.
automatically, like you can separate the pools and then automatically, like managing that infrastructure is usually one of the biggest things as well. Like that's why people go to public cloud. I don't want to manage none of that. Can we just plug and play?
And it's very much the idea is that you don't have to manage that infrastructure. So it is plug and play. So to expand the environment, it's 5 cables and you don't touch the keyboard. And it makes that resource available to the entire cloud. So if you add another 1/4 petabyte of storage, it's there and it's ready to go. You don't have to manage it. It's exactly the same. It's that principle of I love the public cloud because I don't have to worry about my infrastructure. I don't have to sit there, put an OS image on it. Is it the latest one? Like, have I got my DNS right? Have I given it a host name that already exists? Like all of the, rookie 101 things, which just chew out days and days and days of managing infrastructure. And the ability to separate that out. So it can be a single environment, but yes, there's a SAP database. We don't want people futzing on that hardware. So we can pin it to that tenant. So we can have the accounting group as a tenant, and that very, very fast pool of storage can only be used by those guys.
Multi-tenancy at its finest.
So it's, there we go, exactly. And it really is that idea of proper, secure multi-tenancy.
Yeah.
So you can sit and run those departments alongside each other and they can't mess with each other's business. And we see that in the government space where we're running a single environment with separate security levels alongside each other, which everyone says you can't possibly do.
What's your biggest node, no, biggest install?
Biggest install would be in Australia, actually. That's 16 petabytes.
Is that a single cluster?
Single cluster. Yep.
Wow.
Yeah.
Okay, but just one of those?
Did that answer the question?
Just one of those? Only one?
That's the biggest
Oh,
one.
that's the only one. Okay. I mean, it's all right.
We've got a 9 petabyte,
Bigger.
9 petabytes in a manufacturing site.
Yeah.
So, and that's an interesting one. They have a very expensive camera that takes photos of silicon wafers. It's a legacy environment. It used to talk NetApp language. They took the NetApp and put it in the bin, and it goes straight into HyperCloud. And what ends up happening, and we see this all the time, is people start with solving the problem at hand. In that instance, it was storage. And then they go, hey, I've got like this weird little thing that runs an agent for this thing. Could I also run that? And you go, yes, you can. So you can take some Rocky VM images as an example and put that right on top of what you bought as S3 object storage. And that other legacy is now 2 more Dell boxes that you don't need to manage, you don't need to support, and it all just sits inside the one environment.
Regarding storage, do you use the, in the backend, it's going to be a block storage, right? Or it's object storage? It's totally object storage. Okay, and the second one, it's a region dependent, so you can introduce synchronization between the regions that are not very close to each other. Like maybe on the positive side of the country.
Mm-hmm.
So asynchronous.
So we can do a couple of options there where we can have basically multiple sites that replicate to each other or interact with each other. We can also
So you're doing a multi-cluster?
Yeah, we can. Yeah, and so they can either be standalone, replicate whatever you want for like maybe a DR, but you can also make that just one big cloud.
All right. And how are you dealing with witness in that setup?
I'm going to let
All right.
Charles answer.
Okay, no problem.
And I mean, while we're on that topic of reliability or recoverability, like, are you guys, do you have the software and the orchestration to handle all of that as well?
Backup and DR and
Yep.
everything to protect that.
Yeah, so I'll let Charles kind of elaborate on this, but at a high level, we have what we refer to as a marketplace. Think of it as templates. And so then we partner with both virtual appliances that we might design and build ourselves, but also folks in that DR space, as an example, Veeam, Commvault.
Yep.
So if you're already a Commvault shop, I'm not asking you to step away and do something else.
Just
You
plug
can
back
plug it
into
in.
yours with, yep.
And then you can do a number of things, which is you can also back up the VMs that are sitting inside HyperCloud into HyperCloud, or you can just use HyperCloud as a way to back up some other infrastructure that you may have. And that's going to grow out over the next 12 months around those partners that are sitting in that kind of marketplace from alliances perspective. So today it's Veeam, it'll be Commvault, Fortinet, Cisco. We'll kind of run the book on those folks.
So you were saying they use the HyperCloud object storage as the target potentially for other systems and such that are being backed up by Veeam, Commvault, et cetera. Yep.
Yeah.